Welcome back. Today we're going to talk about how you can solve multiplication problems using decimals and decimals with whole numbers. So let's go ahead and get started on this. Let's say we have a problem like 42.3 times 5.9. All right, well, when we're doing multiplication with decimals, the first thing I would strongly suggest that you do is estimate what you think the answer is. What I find students making the mistake more often than not is multiplying, having the right digits, but putting the decimal in the wrong spot. So making an estimate will give you an idea, is my answer close? Is it nowhere close? And it will at least get you in the ballpark at least if you have the correct digits. So I would start off by saying, well, I'm going to make this as easy as possible. I have 42 is close to 40, and 5.9 is close to 6. And so my answer should be close to 240. So again, my answer should be close to 240. We're going to go ahead and try this problem out and see what we come up with. Now, again, when I'm dealing with multiplying decimals, what I like to do is I just set it up as if it is a whole number. So I would set it up as 423 times 59. And now I can go ahead and put my decimal points in. So I have a decimal point right here, and I have a decimal point right here. I'm going to go ahead and begin my multiplying. So I have 9 times 3 is 27. Bring down my 7, carry my 2. 9 times 2 is 18, plus 2 is 20. Bring down my 0, carry my 2. And then 9 times 4 is 36, times 2 is 38. Okay, now when we're multiplying by two-digit numbers, what we're really doing is we're multiplying, 423 by 9, and then 423 by 50. So I'm going to put a 0 here, since I'm multiplying by 50, but here I'm just going to be using the 5, okay? So I'm going to cross these out. I'm going to multiply 5 times 3 is 15. Carry my 1. 5 times 2 is 10, plus 1 is 11. Carry my 1. 5 times 4 is 20, plus 1 is 21. Now I'm going to go ahead and add. 7 plus 0 is 7. 5 plus 0 is 5. 8 plus 1 is 9. 3 plus 1 is 4. And then the 2 just comes down. Now here's the last part. This is a very critical part. I need to find out how many digits were to the right of the decimal in the problem. So I have one digit here, and then the second digit here. 2 digits to the right, therefore I have to have 2 digits in my answer to the right, and so my decimal point will go right between the 9 and the 5. And if you look at my answer, 249.57, that is very, very close to our answer estimate of 240. Again, that is why I make sure that I put an estimate, so when I do my problem, I have an idea if my answer was correct. Now, doing an estimate will not prevent you from making mathematical errors. If you multiply 9 by 2 and you think it's 16, doing the estimate will not necessarily help you with that. It will help you, though, if you think the answer is 2.4957, 24.957, 2,495.7. It will let you know if your decimal is in a logical place. That is the reason we do estimating. Let's go ahead and try another problem. Let's say in this problem, we're going to do a whole number times a decimal. So in this problem, we'll do 3.27 times, we'll do 23. Again, I like to have an estimate just to make sure I'm correct. So I'm going to make the 3.27 into a 3. And I can go ahead and if I want to, I can make it 23. If I want to make it really easy, I'll just make it 20 or 25 even. I'll do 25. And so 3 times 25, that's 3/4, which equals 75. So my answer should be close to 75 when it's all said and done. Let's go ahead and try this problem and see how close we are. So I'm going to bring my 327 down times 23. And now I'm going to go ahead and put in my decimal place, which is right here. Okay, let's go ahead and begin our multiplying. 3 times 7 is 21. Carry my 2. 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9. It's very important when you're doing this to be neat and stay with your columns. Therefore, you won't make any unnecessary errors that you would have by swaying all your numbers to the right or to the left, putting them in the wrong column. So try to be as neat as you possibly can. Now I'm going to multiply by the 2, which is in the tens place, or the second place over. So I'm going to go ahead and put a 0 here. And I'm going to have 2 times 7 is 14. Carry my 1. 2 times 2 is 4, plus 1 is 5. And then 2 times 3 is 6. Time to add. 1 plus 0 is 1. 8 plus 4 is 12. Carry my 1. 1 plus 9 is 10. Plus the 5 is 15. Carry my 1. 1 plus 6 is 7. I have 2 numbers to the right of the decimal. Therefore, I need to count over 1, 2 numbers here, and I get 75.21. And my answer is very close to my estimate. All right, so we're going to do one more just to make sure you guys are getting this. Oh, man, having a hard time here. Let's move this down. I think this will make it easier. All right, here we go. There we go. Get everybody together. Group you. Slide you over. Okay, so what happens if I multiply by a number that is less than 1? All right. On this problem, let's say that I have 700, or no, we'll do 72.3 times 0.5. Or no, we'll do 4 times 0.4. Okay, so in this problem, I'm going to estimate that this is close. I'm going to say the 0.4 is close to 0.5 or half. And then I'll make the 72 into a 70, just to make the math easy. Half of 70 equals 35. So my answer should be close to 35. Again, half of 70 is 35. If I was multiplying 70 by 1, it would be 70. If I was multiplying 70 by 0, it would be 0. 35 is right in the halfway mark between the two numbers. Let's go ahead and set this problem up then. Again, I'm going to do 723 times 4. Now I'm going to go ahead and put in my decimal places. I have a decimal right here, a decimal place right here. This time the decimals line up. However, they don't have to. Just when they do, they do. Don't always, you don't want to line up the decimals every time because that is something you do with adding, subtracting. They can, but oftentimes they don't. So line them up first as if they're whole numbers, then put your decimals in. Okay, you'll avoid costly mistakes by doing it this way. Let's go ahead and multiply. 4 times 3 is 12. Carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 7 is 28. And I have 2 numbers to the right of the decimal. 2 numbers to the right of the decimal. I get 28.92. Now, that is still very close to 35. Now, again, we bumped that up from a 0.4 to a 0.5. So in our estimate, we were multiplying by more than what the actual number was. Therefore, our number, it's not surprising that our estimate's a little bit bigger than the actual. The big thing we wanted to see was it was closest to 35. We didn't get like 2.892. We didn't get 289.2. We get 28.92, which is close enough. Okay, well that is pretty much it for our multiplying and of decimals. I hope this was helpful. Have a wonderful, wonderful day. Let me move this up for you.